Assalamu alaikum wa rahmatullah and welcome to the Matric Revision program on the Voice of the Cape. And this with myself, Amir Adams, as your presenter for these Matric Revision sessions. Today we continue with our next session in the Matric Revision series, where our facilitator today will be covering content for mathematics. The Voice of the Cape's Matric Revision sessions on the Facebook page as well as on the YouTube page of the Voice of the Cape is in conjunction and is being sponsored by the Two Oceans Graduate Institute, an accredited online platform where you can become a primary or high school teacher by studying in the privacy of your home. You may visit their website, and that is www.togi.ac.za, or you may call them on 021 829 7015. So, without further ado, as a means of introducing today's session, today we have the honor once again to be interacting with today's esteemed facilitator for Mathematics Paper 1, and that is none other than Imam Natheer Hendricks, who is a tutor and the head of Supreme Scholar with a degree in mathematics as well as computer science. Imam Natheer Hendricks has also more than 10 years' experience teaching and tutoring both locally and internationally with the subject. Today, we'll specifically be covering algebraic equations and number patterns, and of course, all of this in conjunction with the matric revision for this year for all the matriculants and those specifically who are writing pure maths, inshallah, those who are preparing for the trial examinations as well as those who are preparing for the NSC examinations. So, just as a reminder to all of our beloved listeners, as you can see up on the screen, this is a matric revision sessions that we are running on the Voice of the Cape for this year 2024 in collaboration with our sponsor, and that is the Two Oceans Graduate Institute, inshallah. Without further ado, we immediately hand over to our esteemed facilitator for today's paper, and that is none other than Imam Natheer Hendricks from Supreme Scholar, who will be covering the content for Mathematics Paper 1. As a reminder, of course, to all the parents and all the students out there, please like, share, and subscribe on the YouTube and Facebook pages of the Voice of the Cape, and ensure that all of those who are preparing for this upcoming examinations have this content ready for them in order to further succeed in the exams. Without further ado, we hand over to our esteemed facilitator, Imam Natheer Hendricks.
Assalamu alaikum wa rahmatullah. Shukran for having me. Bismillah. So let's get into session number 2, inshallah, on mathematics. So alhamdulillah, we're continuing from where we left off in the session yesterday. And yesterday we tackled, just a reminder, we looked at starting with the end goal in mind. We looked at an overview of topics from paper 1 and paper 2. Then we went into some algebra, and we defined very clearly and as simply as possible what algebra is. We looked at some basic algebraic equations, applying some basic rules and principles from algebra. We looked at a quadratic equation example, and we looked at some typical exam equation questions. Today, inshallah, we're going to be doing the following. We will take a little bit of a deeper, detailed overview, look at the typical question 1 and question 2 of paper 1. We're going to be looking at that and just giving you an overview, a little bit more detailed overview of what you can expect for specifically question 1 and question 2 in your paper 1 final exam, which will take place at the end of this year, inshallah. And then we're going to be looking at just a point. One of my students pointed out to me that there was something that we mentioned in the previous lesson that I need to clarify. So just a point of note from the algebraic equation from the previous lesson that we conducted yesterday. And then we're going to be looking into some more complex algebraic equation examples. We will be looking specifically at another algebraic equation, and we will be looking at an inequality, which falls under the section. And then we will start with number patterns. Then we will look into number patterns, which is the second section, typically the next section, a very big section in your final exam that you can expect questions on. And so we will look at what are number patterns. We'll look at three types of patterns typically dealt with in your grade 12 exam, and what you can expect to be tested on in your final exam. We will look at some basic examples, and then we will look at the typical exam question, inshallah. So that's the plan for today, and let's get straight into it. Bismillah. Okay. So a detailed overview of a typical question 1 and question 2 of paper 1. In the previous lesson, we said that that typically algebra and equations is typically about 25 marks, basically question 1. What I've done is I've taken a screenshot or snippet of question 1 from the as you can see on the screen, from the Department of Basic Education past paper, last year's final paper, 2023's final paper, right? And what I wanted to basically just point out is the following. This is typically what the question looks like. Obviously, it's not the same. I mean, the numbers will change stuff, but typically you can expect that the first question is going to be a simple quadratic equation that usually you will solve using factorization. And there's the sort of mark allocation. And you can see that the entire question 1 is about 24, 25 marks. It's about 25 marks plus minus. It could be 27 marks, or it could be 23 marks plus minus, right? That's basically how it normally is. So you have question 1, which is a typical algebraic equation, which we've dealt with in the last session. Then we have question 1.1.2, which is also a quadratic equation. And then they have this in this brackets over here, answers correct to 2 decimal places. And usually, just as a tip, while we're talking about this over here, which we're going to unpack a bit later in the next slide, usually they say you give your answer correct to 2 decimal places. So when they say this, you need to actually give your final answer in a decimal form with 2 decimal places, and you actually get marks for that, right? So if you leave that out, then you don't. And this is also a hint, by the way, that if they ask you to give the answers correct to 2 decimal places, it's a hint that you should apply the quadratic formula, which we unpacked last week, which is x is equal to minus b plus minus square root of b squared minus 4ac over 2a, right? And that's 4 marks. And then gradually, as you move through the questions, and this is generally the case for most of the questions set up in the question paper, as you move through the questions get considerably harder. There are 3 types of questions that are coming in the final paper. You get what we call routine procedural questions. That's what they call it. It's basically, problems that you've dealt with, and you've seen many of those kind of problems in your classes, and you've dealt with those like in your classes. Then we get what they call so routine and procedure questions, and you get complex questions, which is slightly harder. You might have seen some of it, but you might have not seen exactly how that. So it's like applying a few principles from different sections in order to solve the problem, a little bit more complex. And then you get what they call problem solving questions. Every question is structured like that. So the first 2 questions is typically questions that you've seen, and then when we get to question even 1.1.3 here is a question that you should be a little bit familiar with, but this would likely be like a complex question. And then you get then we move further, simultaneous equations. This is routine. Simultaneous equations is routine question, right? Just some algebra involved in here, maybe a mix of some complex things in here. But if you know your algebra well, then you should be able to solve the simultaneous equations. And then the last question is usually a problem solving question. It's something that you need to think a little bit out of the box to solve, right? That's typically the sort of structure of question 1, and it's 25 marks, right? So it's important to know that. Why? Because you can expect to struggle a little bit with the last question. You can expect that it's going to be a sort of a trick question, or there's something in there that you need to focus on thinking about that's a little bit out of the box, that's not that obvious. So you can expect that. That's important for many reasons. One of the reasons is, remember, you are sitting in an exam, and in the exam you have 3 hours to get as much marks as you can, and so you're stressing, right? And so now you come to question 1.3 and you're like, oh my god, I have no idea what's going on over here. Don't allow that stress to affect you negatively and cause you to make mistakes in the rest of the paper, right? You can expect that the last question the last question in in almost all the sections is going to be a problem solving or difficult question. Okay, so that's some insight into question 1, and then we look at question 2, which we're going to unpack a little bit of this today. We have arithmetic. This is number patterns basically. So we have an arithmetic series, which we will talk about. Again, similar thing, right? As you go through the questions get a little bit more tricky, right? And that's about 16 marks. So this is an overview of the typical. It's not exactly the same like this, but it's similar. You could use this as a guideline. And one of the great ways to study and prepare for your final exams is to actually go through as many past papers as possible, and you will see the patterns of how questions are asked and stuff, and so you will get used to the structure of the paper, and so you don't have any surprises in the exam, right? Surprises can cause you to become more nervous and stressed, and that can have a negative effect on your performance in the exam. So that's some insight into the typical question 1 and question 2 of paper 1. So let's move on. Okay, so here's a point to note from the algebraic equation from the previous lesson. If you've watched the previous lesson, which was on yesterday, you would have remembered that we dealt with this question over here, and we unpacked this question using the quadratic formula, and we came out to our answer, which is 3 plus root 33 over 4. So let me get my board out quickly. So we came out to this answer over here, and what I forgot to mention yesterday is that as you see in the second question, when they say usually in brackets, the usual second question in a final exam is correct to 2 decimal places. They actually want you to simplify this answer and actually write it as a decimal. So all you would have to do here then is you would have to, let's get my pen out. You would have to go further than this. So this is not you don't leave it as this. If you left it as this, you would have actually lost marks because you didn't put it into the final 2 decimals. So all you do is you take this number 3 plus root 33 over 4 and you put it into the calculator, and you should put it properly into the calculator, right? Make sure that you put it into the stuff properly, and if you do that, you would get an answer of something like 2,186, right? And if you round that off to 2 decimal places, I'm not going to go into this right now, but 2 decimal places would be 2 numbers after the decimal point. You look at the third number is greater than 5, therefore the second number goes up, and so it will be 2,19, right? So that would be the final answer, and you would actually get a mark for writing it in that form. And then you do the same thing with 3 minus the root 33 over 4, and if you did that, you would have gotten an answer of negative 0, just writing, let's get it right here, negative 0, negative 0, 8, negative 0, 686, if you put it correctly in your calculator. 686, and again the 6 is greater than 5, therefore the final answer to correct 2 decimal places would be negative 0, 69. Okay, so that's just something that I had to mention from yesterday's lesson, that it is important to round off and correct your answer to 2 decimal places as was requested in the exam paper. Okay. All right, so that's the point that I wanted to mention from the previous class. Let's move on. Okay, now we're going to look at some more complex algebraic expression, or actually, the setting is incorrect. More complex algebraic equations. Right? An expression is simply a plus b plus c, or ax plus bc. Sorry, ax plus b maybe. And an equation is where you have ax plus b, or something x plus, is equal to some number. There's an equal sign. So we're looking at algebraic equations. Just forgive me for the incorrect heading there. It's algebraic equations that we're looking at, right? So we're going to be looking at this, and this is taken from the past paper. We're going to be unpacking this and just solving this one together. Square root of 2x plus 1 is equal to x minus 1, and that's worth 4 marks. So let's just get our hands dirty a little bit and just solve that question over there. So we have that question, which is the square root of 2 x plus 1 is equal to x minus 1. Okay. So how do we go about solving this question? Let's just make it nice over there. Okay. Let's have a look at that. Okay, so how do we go about doing this? Okay, so the first step, if you look at this equation, the first step would be we want to, there's something complicated here, the square root. The square root is causing some issues here. How do we know the square root is causing some issues? Because once we square root numbers under the square root and we've got a plus sign, then, you know, it's tricky to move these things around. So one of the first things that you want to do whenever you see a square root, one of the first things you can try to do is to try to get rid of the square root. And how do you get rid of the square root? Well, a way to get rid of something is to do the opposite of that thing. So if I have, for example, x plus 1 is equal to 2, if I wanted to get rid of the 1, I subtract 1 on the left-hand side. And what I do on the left-hand side, I do on the right-hand side. So I subtract 1 on the side as well, and I end up with x is equal to 2. So that same idea, it's an algebraic idea. That same idea gets applied here. I want to get rid of this square root. So how do I do it? Well, the opposite of square root is to square. So if I square this side, that square would cancel out the square root. But what I do on the left-hand side, I have to do on the right-hand side. So I do the same thing here. I square the side over here. And then I end up with 2x plus 1. 2x plus 1 is equal to x minus 1 squared. Okay. 34. Okay. So now I've got something that looks a little bit easier to deal with. Now I've got rid of the square root. Okay, so now what we do is let's just expand this x minus 1 squared by multiplying it out. And there's two ways to do it. There's a shortcut way. The shortcut way, I'll explain to you. The long way is writing it out, extending the brackets, and then you're multiplying the first term by the first term, the first term by the second term, which we dealt with in yesterday's lesson. But I'm going to show you a shortcut, right? A short way to do this. The short way to do this is first square the first term. So what's x? Square the first term. X squared, correct? Then you take the first term, you multiply it by the second term, including the sign, and you multiply the answer by 2. So x times negative 1 will be negative 1x. And that multiplied by 2 will be negative 2x. And then for the last term, we're expecting 3 terms. For the last term, we take the last number, including the sign, negative 1, and we square it. And negative 1 squared will become plus 1. You can, go do it on your own and just see if you multiply it out, you get the same answer. Okay. So now we have 2x plus 1 is equal to x squared minus 2x plus 1. Okay. Next step would be to move all of the terms on one side. So we could move this way. We could bring this quadratic term over this side, or we could take these terms over that way. Right? Either way, it doesn't really matter. Right? By convention, you used to having the 0 on the right-hand side, but it actually doesn't matter what side the stuff is. You understand that one thing is equal to the other thing, whether you have it on the left-hand side or the right-hand side, it's still the same thing. So I prefer that we move the 2x over and we move the 1 over, right? And if we do that, then we have 0 on the left-hand side. We have x squared here. Sorry, that looks like a 3. Give me. We have x squared here minus 2x. And so and minus 2x plus 1. Let's do that. And then I brought the 2x over, so it became negative 2x. Remember, when you take over the equal sign, the sign changes, and you got minus 1. And now, all I have to do is I have to sort out the like terms. So I have x squared over here. There's no other x squared, so x squared remains x squared. There's a minus 2x and there's a minus 2x. So that goes together. Why? Because that's the same term, right? So in essence, it's an x over there, but it's going to be minus 2 minus 2. How does that work? Well, if I have apples and apples, if I have 4 apples and 3 apples, I can add them up to have 7 apples, right? Anything that's the same, I simply just add the number. So minus 2 will be minus 4x, right? And then the last number here is 1 minus 1, and that's obviously going to be 0. So we have 0 is equal to x squared minus 4x. If you don't feel comfortable working with the 0 on the left-hand side, you can swap it around. It doesn't change anything really. So x squared minus 4x is equal to 0. It's exactly the same as saying 0 is equal to x squared minus 4x. Don't get confused. I did not take stuff over here. I simply just rewrote the equation with the expression on the right-hand side. Okay, so now we have something that's easier to work with. We've got a quadratic equation. And from yesterday's example, one of the ways to solve a quadratic equation is to factorize, especially if it's equal to 0, right? So we've got it in the form where it's equal to 0, and now we're going to factorize. What is factorization? Yesterday we did a certain form of factorization. Here, this is a more simpler form of factorization. What is it? It's taking out a common factor in both terms. So if you look closely, you will see that there's an x squared here and there's an x there. What does that mean? What does x squared mean? X squared simply means there's two x's. You could also write this as x times x, right? And take the squared away. So what does that mean? There's a common factor between these two terms, right? What do we mean by that? There's one x here and there's one x here. So x is common in both terms. Therefore, I take x out as a common factor. And then I open a bracket and I say x multiplied by what gives me xx? Well, x multiplied by x gives me x or x squared. And x multiplied by what gives me negative 4x? Well, minus 4. Minus 4 times x gives me minus 4x. And that would be the factorization. And then following from the principle that we dealt with yesterday, where if two things are multiplied by each other and they're equal to 0, then there's only two possibilities. The one possibility is the first term equals to 0, or x minus 4 equals 0. Okay. And then it follows then for us to simply just simplify the second answer here, because if x is equal to 0, x is equal to 0, you can't do anything with that, right? If x minus 4 is equal to 0, then x must be equal to 4, and that is your solution. Okay. So that's that question over there. 4 marks, and that is that question. How to deal with that question? Okay, let's look at the next question, which is an inequality. What is an inequality? Well, a normal equation says that one expression is equal to the other expression. An inequality is saying that the expression on the left-hand side is not equal to the expression on the right-hand side, right? It could have equal to, but it's saying in this case over here, let's just get to the board and deal with this one over here. Go across. Okay, so let's get, what was that question? X squared minus 3 is greater than 2x. X squared minus 3 is greater than 2x. This is also a question worth 4 marks. So let's unpack this. How do we solve this? Okay. The difference between this and a normal equation is that an equation tells me that the left-hand side is equal to the right-hand side, whereas in this case over here, we're saying that the left-hand side here must be greater than the right-hand side. So naturally, because it's, there is some principles that we will use from how we solve normal equations to solve this. So let's unpack what we're going to be doing here. And maybe we should translate this into English. What this actually is asking is, what number squared minus 3 is greater than 2 multiplied by that same number? That's what this is asking you in English, like a word sum, if you want to call it that. So how do we solve this? Okay. So the way we solve this is as follows. The first thing you could do is you could try to get this in the standard form where you have all the terms on the one side, especially when you're dealing with the quadratic, because then you can have it in its standard form, and you have 0 on the other side. So it's simply the case of us taking over the 2x, right? And you have the same thing that happens. If you take over the 2x, then you will change the sign. So x squared, this will become x squared minus 2x minus 3 is greater than 0. Something important I need to tell you. So that's what we have. There's something important I need to tell you. If you have to divide by a negative to get some stuff over. So remember, when we're moving over here, we just subtracting. Like, how am I? What does moving over mean? Moving over means I'm taking 2x away from this side, and I'm taking 2x from that side, so it balances out, right? So it doesn't have to really change much. But if I was dividing to get rid of a number on this side, and I had to divide by a negative, then the inequality sign will flip around. We're dealing with negative numbers here, or we're dealing with one is greater than the other one. So if I had to, for example, divide by something here to actually get this thing over, then I would have to change the direction of the symbol, right? That's something important to note. In this case, we don't have to do that because we're not dividing by any negative number over here to get that thing over. We're just subtracting -2x. I hope that's clear. Okay, we can unpack that in another lesson. Don't want to spend too much time on that right now because this is a bit of a simpler example. Okay. All right, so let's go on now. So what do we do now? Now what we must do is we factorize. Why? Because there's something important that's happening over here. We want to see, essentially what's happening over here is the following. This is a quadratic equation, as you know. And if you remember from graphs, just to remind you, if I have a graph f of x is equal to x squared minus 2x minus 3, right? If I have a graph like that, that's actually a quadratic equation. And a quadratic equation can be represented as a parabola or a parabolic graph, right? And if you remember, a parabola looks like this. So what essentially this is asking you in English is, this is some kind of this is an equation. This is some kind of function, right? We're asking, where is this function greater than 0? In simple terms, where is this function positive? Because anything greater than 0 is positive. That's what this equation is asking. Where is x squared minus 2x minus 3 positive? That's what this thing is asking. That's all it's asking in English, right? So in other words, the question is, if I had to look at the graph, where is this graph positive? Obviously, the graph is positive on top of the x-axis. So this part over here and this part over here, right? So we need to actually give the y values. Remember, there's another axis over here. I'm just throwing a rough graph over here. We need to give the y values where the graph is actually positive, and it would be positive everywhere here and everywhere. Yeah, that's actually what that question is asking. So we are actually interested in this number specifically and this number specifically, right? And those two numbers are what we can call it in this context, we call it the critical values. In other words, at that point, whatever that number is over there, when the graph crosses that line, it actually changes the graph from a negative part of the graph to the positive part of the graph. And the same happens on the other side. So we're interested in what those values are. And guess what? In order to find those values, you simply take this equation, x squared minus 2x minus 3, x squared minus 2x minus 3. You simply take this equation and you make it equal to 0 and you solve. And then you'll get your critical values. We call it critical values. You can call it CV, which will be the value there and the value there, where this entire function is actually equal to 0 on the x-axis. So that's what we need to solve over there, right? And so now you can use the quadratic formula, x is equal to minus b plus minus square root of b squared minus 4ac over 2a. You could use that equation or formula, sorry. Or you could, use factorization. I'm not going to go through this again because we have done this. If you do your factorization, get a number a number that multiplies, two numbers that multiply by themselves to get 3, and if you add or subtract, you get -2, then you will come out with the two brackets equal to 0. You have an x here, you have an x here. The two numbers, the two factors that will work here would be 3 and 1. 3 multiplied by 1 is 3, and -3 plus 1 is equal to -2. So -3 multiplied by 1 is equal to -3, and -3 plus 1 is equal to -2. And then if you equate x minus 3 is equal to 0, you will get x is equal to 3, or x is equal to -1, right? See, there's even algebra in solving this equation. Well, there's a lot of algebra. Algebra is everywhere over here. If you're struggling with this concept, I'd highly recommend that you go practice it, because it comes up in many different places where you need to factorize quadratics. Okay. So we have now our critical values, 3 and -1. And now we need to make sense of this on the graph. How does it look? Well, on the negative side, on the left side, this will be the negative number. So this must be the -1, because that's the only option there. And on this side, it will be the 3. So that, what am I saying? In other words, this value over here is -1, and this value over here is 3. And that we can call your critical values. And if you do this in the exam, you can say CV is 3 and -1. You will get marks for that. And now it simply remains for us to answer the question. What was the question? Let me remind you. The question was, where is this graph positive? Where is this equation positive? In other words, greater than 0 or positive. If it was the other way around, it would be, where is this equation negative? But here, it's where is this equation positive? So now we can see, well, it's positive here, right? So we draw a straight line over here, and we say, okay, wherever, listen carefully, wherever the value, the graph is moving on that side of -1, if it's going on that side of -1, then the graph is positive. See, this line over here is towards the left of -1. So the first answer would be x must be less than -1, right? Wherever x is less than -1, remember this graph goes straight up. It doesn't come down again. So wherever x is less than -1, the graph will be positive. Or on the side, you can draw a straight line over here. Wherever, so we're looking at when the graph passes that point 3, then the graph starts becoming positive. So wherever, and it's moving towards the right, so wherever x is greater than 3, wherever x is greater than 3, the graph is positive. Right? I hope that is clear. That is how you deal with such a question. There are so many students who get confused with this part over here. They solve this up until the critical values, and then they don't know how to read the graph, right? So that's how you read it. Right? You draw the graph, you get the critical values, and then you check on the left hand side, on the right hand side of the value, is it positive or negative? And obviously, this thing was swapped around. If we were looking for x squared minus 2x minus 3, where it's less than 0, then the English question translated to English would be, where is the graph negative? And then we would obviously take the values between -1 and 3, which would obviously change the answer. Okay. So that's the inequality. And we could deal with more. We'll see if we do another one maybe in the next session. But we need to move now to our next section, which is number patterns. Okay. So let's take a breather. You are able to pause, or later on when this video is live, is on the stream, you will be able to pause and maybe take a breather. I don't have that liberty. I'm doing a live session here, so let's get on. Okay, so let's talk about number patterns. What is a number pattern? We'll start simple. Try to just define what a number pattern is. A number pattern is simply, very simply, just a list of numbers that follow a certain order or rule. That's all. That's it. That's all it is. Right? A list of numbers that follow a certain order or rule. When we say rule, we mean you can calculate. You can say, okay, I'm adding 2 every time to get the next answer, for example. Right? Here's an example. 2, 4, 6, 8. When we count in twos, That's a number pattern. Another word for that is a sequence. It's a number pattern. It's following a specific rule. What's the rule? Just add 2 every single time to get to the next number, right? And so you could calculate what's the 100th number in this specific pattern, right? You can count 2, 2, 2, 2, 2 until we get to 100. That's one way. Or there's a shorter way by using an equation, which we're going to unpack in this, right? So this is a simple number pattern that keeps adding 2 to get to the next number. That's it, right? Okay. So let's just unpack quickly. Let's just unpack quickly important terminology, right? Important terminology. What is a sequence? A sequence is a list of numbers that form a pattern. A sequence is a list of numbers that form a pattern. So you need to get familiar with this terminology, because when these words are used, you need to understand what is actually being said, right? A sequence is a list of numbers that form a pattern. That's it. Understand clearly what we're talking about when we say these numbers. Sequence is a list of numbers that form a pattern. The term, right? The term is T1, T2. Each number in a sequence of numbers. That's what term means. T1, T2. You will see the symbols when we're talking about number patterns. T1, T2, etc., etc. When we use the word term in this context, we're actually just specifically referring to any number in a sequence of numbers. That's all we define, right? Constant difference is something we use as well. Constant difference means the same number being the difference between 2 consecutive numbers in a sequence. So when we talk about this, maybe I just need to explain this a little bit simpler. When we say constant difference, we simply mean, like we look at the previous example. If you look at the previous example, when we say constant difference, we simply mean that the difference between each 2 numbers, the difference between 4 and 2 is 2, and the difference between 6 and 4 is 2, and the difference between 8 and 6 is 2, right? So when we say constant difference, we simply mean if you take the second term and you subtract the first term, you're going to get a number. And if you take the third term and you subtract the second term, you're going to get the exact same number. That's all we mean. Constant difference, the same difference. The same difference. Right? Each number in a sequence of numbers. So constant difference, the same number being the difference between 2 consecutive numbers in a sequence. So that's what we mean when we say constant difference. Then we have this term called general term, and the symbol is Tn, right? The general term is simply the value of any term in a sequence, also called the nth term. So sometimes they will ask you to calculate the general term. What they're asking you to give is a formula that can give me any value in this pattern. So in the previous example, 2, 4, 6, 8, for example, if I want the 100th term, then it will be T100. N over here just refers to the position of the number in the sequence. Right? This is very important to understand this terminology and know what you're talking about. Okay, right? So let's look quickly at 3 different types of patterns. You get 3 types of patterns that you, as a Matric student, need to be. You can be tested on any of these 3 types of patterns in your final exam. The first one is what we call an arithmetic pattern. They also call it a linear pattern in certain instances. Right? What is an arithmetic pattern? I'm going to unpack that. The second type of pattern is a geometric pattern, which we're not going to deal with today because time doesn't allow us. We will deal with it in future sessions, inshallah. And then the last type of patterns is a quadratic pattern. So for today, we're only going to be looking at the arithmetic pattern, but I'm going to give you a very brief definition of what's the difference between these 3 types of patterns. Right? So what is an arithmetic pattern? An arithmetic pattern is simply numbers. It's a pattern. It's numbers that increase or decrease by the same amount each time. In other words, a very important defining feature of an arithmetic pattern is that it has a constant difference. That's all. A sequence, an arithmetic pattern is simply a sequence that has a constant difference. And you must know by now, if you've done word sums, if you remember word sums from previous grades, the word difference in English specifically means minus in mathematics. When they say difference, they're talking about subtraction. difference between two things, it's talking about adding or subtracting. We can say adding or subtracting, but just to avoid confusion, subtracting, right? So an arithmetic pattern, very simply, once the moment I say we're dealing with an arithmetic pattern, you must already know that this pattern, whatever the pattern is, I haven't even seen the numbers yet, whatever the pattern is, you must know that it has a constant difference between each term. That's like a given already if you're dealing with an arithmetic pattern. Right? So if a question comes and says the following is an arithmetic pattern and they give you the numbers, then you already know there's a constant difference. The difference between T2 and T1 is exactly the same as the difference between T3 and T2, etc. Right? A geometric pattern, what's the difference between the two? A geometric pattern is numbers that change by multiplying or dividing, dividing by the same amount each time. What are we saying here? A geometric pattern is simply a sequence that has a constant ratio. What is that in English? Well, very simply, when we're talking about an arithmetic pattern, we're talking about the difference between two numbers being the same, but the difference has got to do with plus and minus. When we're talking about geometric patterns, it's not plus and minus, it's multiplication and division. In other words, term number 2 divided by term number 1 will be exactly the same as term number 3 divided by term number 2. That's all. And that's a defining feature of a geometric pattern. I'll repeat. An arithmetic pattern has got a first difference, a constant difference. In other words, if I add or the numbers are the same, and if I subtract T2 by T1, I'll get the same number as T3 by T2. For geometric patterns, if I divide T2 by T1, it will give me the same number as T3 by T2. Right? And a quadratic pattern is simply numbers that change by adding or subtracting and increasing or decreasing the amount each time. What does that mean? Right? What that simply means is it is a sequence that has a constant second difference. So you have the pattern. You have the first differences between the pattern. For a quadratic pattern, the first differences is not the same, but the differences between those differences is the same. That's what we mean by second difference. That is the simplest difference between these three different patterns that you need to know. And for today's session, we're only going to be looking at some examples of arithmetic pattern. Okay, for each of those patterns, you get general formula, right? So for this pattern over here, the general formula for an arithmetic pattern is usually in this form: Tn is equal to A plus n minus 1 D. And these letters mean something, right? A usually means the first, the value of the first term in the pattern. So if the term starts with 2, if the sequence starts with 2, then A will be 2, etc. D is the constant difference, whatever that constant difference is, and N is the term position number. So if I'm busy with term number 1, then N will be 1. If I'm busy with term number 2, then N will be 2. If I'm busy with term number 10, then N will be 10, etc. Right? You need to know this formula. If I remember correctly, this formula is not given to you in the I stand on a correction. There are certain formulas that's not given to you. I'm not sure if this one is given to you in the formula sheet. It would help you to know this and remember this formula. For any arithmetic pattern, Tn is equal to A plus n minus 1D. All you have to do is you have to put a value in for A, which would be unique to the pattern that you're dealing with, and a value for D. Right? Something important that you need to remember, which I said a couple of times, is that T2 minus T1 is equal to T3 minus T2 is equal to T4 minus T3. What do I mean by that? What I mean by that is term number 2, the value of term number 2 minus the value of term number 1 is the same as the value of term number 3 minus term number 2, and it is the same as the value of term number 4 minus term number 3, and you can go on like that. Right? Term number 100 minus term number 99 is going to be exactly the same number because it's an arithmetic pattern. Okay. A basic example. Consider the following sequence: 5, 7, 9, 11. Well, term number 1 in this case over here is 5. Therefore, if I had to find I had to put a value in the formula, it would be A is equal to 5. And if I want to find D, I simply take T2 minus T1. 7 minus 5 is 2. 7 minus 5 is 2, right? 9 minus 7 is 2, etc. 11 minus 7 is 2, right? So that's it, right? So let's look quickly at an exam question and we're going to end on this, inshallah. This is an exam question. We're just going to deal with 2.1.1 and then we will end. Okay. So we're looking at 7, 12, and 17. So let's see. Right? Bring up the board over here. So we're looking at the pattern is 7, 12, and 11. So let's look. Don't worry about the pluses over there. The pattern is 7, 12, and then 17. Right? And they're asking you for the value. They're asking us for the value of term number 91 in this arithmetic. It's called the series. The reason why it's called the series is simply because instead of there being a comma, it's plus. It's adding things, right? We're only going to deal with t number 91. How do we find the value of the 91st term in the sequence? Well, how do we do that? Firstly, this is T1. This is T2. This is T3. And so on, right? And it goes all the way until we say Tn, where n is any number. In this case over here, we're looking for T number 91. That's what they're asking, right? So we need to find the 91st term somewhere here. 91st T91 will be some. We need to find the value of T91. Well, how do we do that? The first thing we're going to do is we're going to find the general formula. So we remember that Tn is equal to A plus bracket n minus 1 t, right? Now we need to find a value for A and we need to find a value for D. Well, A is 7. So we could just put 7 there. A is 7. A is equal to 7. And D, what is D? Well, 12 minus 7. It's going to be T2. You can say D is equal to T2 minus T1. That's the way you work it out, right? And you expect it to be the same as T3 minus T2, so you can take any of those, right? And if I take 12 minus 7, I will get 5. 17 minus 12, 5, the same thing. So D is equal to 5. And then we simply just put these values into our general formula. Tn is equal to 7 plus n minus 1. Don't put a value in for n yet. And the difference is 5, so it's multiplied by 5. That's it. So now we have our general formula, and this general formula will allow us to find the value of any term in the sequence. And now they're asking us for T91. Well, what we simply will do here is we'll say T91 is going to be equal to what? You see this n over here goes with that n over there, right? So we're going to say T91 is equal to 7 plus 91 minus 1 multiplied by 5. That's it, right? And then we can do the calculations. 91 minus 1 is 90. 90 times 5, you could do the calculation, right? 90 times 5, 7 plus 90 multiplied by 5. What is that? Just get a calculator. My brain is a little bit lazy right now, so I'll just use a calculator. Give me a calculator here in front of me. You could do this value as well. So we have 90 multiplied by 5, right? 90 multiplied by 5. Sorry, 90 multiplied by 5, 450, and that would mean that the value, the answer here is 457, because 90 multiplied by 5 is 450 plus 7, obviously, which is equal to, that was an easy number. I didn't actually need a calculator. Yeah. And then we have 457. And that's going to be the value of the 91st term, right? Just to remind you again, the value of the 53rd of the value of the 91st term. So this value over here is 457. And likewise, you could calculate any number. You could calculate the 1000th term in this series over here, sequence over here. Okay, I think that's enough for today. We will end on that. In the next lesson, we will continue with some number patterns, perhaps look at some geometric and quadratic problems. And we're going to move on, inshallah, to the next sections. I will conclude on that. وصلى الله على سيدنا محمد سبحانه وبحمده سبحانك اللهم وبحمدك نشهد أن لا إله إلا أنت نستغفرك ونتوب إليك. شكرا. I hope this was beneficial. السلام عليكم.
Alaikum salam wa rahmatullah. We say shukran, jazakallah khair, Baitra Makasi, thank you very much to our facilitator for today, and that is none other than Imam Natheer Hendricks, one of the tutors and the head of Supreme Scholar, who so beautifully gave us guidelines as to how we should prepare for the upcoming matric paper of mathematics, specifically content for paper one. And notice I speak in the inclusive we, because we consider all of ourselves, even those who are not in matric anymore, still to be part of this process, whereby we know friends and family members that are in matric. So we are all there to support you, inshallah. And we would like to once again thank all of those who have basically viewed today's session. And just as a reminder, in conclusion, please share this page with all of your friends as well as your family members who are currently in matric and who are basically embarking upon this process of studying and preparing and practicing for the upcoming trial examinations, as well